Hello, how you getting on there? Welcome to Create Now. And we're talking about production again. So we have been talking about digital audio workstations and the history on how it became digital. So we've talked about all the way back to wax cylinders, through into magnetic tape, into vinyl, into ones and zeros, into digital, and I don't know, digital converters, all these different things. We've talked about what happens on each channel. So you got the mute button there. Often when you press that, it goes red. Often when you, or kind of red. Often when you press the solo button, it goes yellow. Record enable is a very, very, very important button for your digital audio workstation. Your digital audio workstation is very similar to the mixer, the hardware mixer. So on a track, you have to select the input, because if you have a sound card or something like that, you need to select where the input's coming from. So with a hardware mixer, that would always be you're sticking your guitar lead in, which is a 1/4 inch jack, usually mono. There you are. So it goes in, it gets the organised, and the volumes get all organised in your mixer. You have all your signals going in, you mix them all up the way you want them, different volumes. You might put a little bit of an effect on it, and then you send it out in the stereo out to your left and right. Okay. So there's a stage there in between the mixer and the speakers, and that is a power amp. So often that's the big heavy thing in the mixer that makes it so heavy, and all that's doing is just turn up the volume. And if you have two speakers and one of them's heavier than the other, that's because the power amp is in one of them. So there's passive speakers, active speakers. The active speakers have the power amp built into them, active, and passive, which means like no electricity or whatever. The power amp power has to come from an external amplifier. So often the amplifier is built into the sound mixing desk. You'll know if it is because the amplifier will be fucking huge. Let's say these amplifiers are quite big. They're quite big, and sometimes if they're used to drive big bass bins, these are speakers like the size of a child, which the speaker diameter may be like 1.5 foot or something, blowing it, moving some serious air with those bass bins. You gotta have a lot of electricity going to them, so that's why you need a big amp. And sometimes the amplifier is quite big, like it would fit in a double 19-inch rack. So that's what I mean by big. So is it 19 inches across and like fucking 3 inches deep and like, oh god, like 8 inches width. Okay, I don't know how to describe it. Right, it's big enough anyway. Okay, so signal chain. We might have a look at signal chain today. Okay, we'll have a look at signal chain. So it starts off with the source. So right now, I'll talk you through the setup I'm using right now, just as an example. So I'm talking, how are you getting on? That's, I'm moving air with my mouth. Alright. Those vibrations are causing the diaphragm and the microphone to move in and out, pulsate, so energy. There's two little wires on that diaphragm which amplifies the signal of the diaphragm moving because it's too low to be audible. Alright, so this was where a mic pre comes in. Alright, so you got to crank that volume up so you'll be able to hear it. And you need a good mic pre, because if you don't have a good one, there'll be a lot of background noise like in the background. And it may muffle the sound. So so you have your diaphragm, it's moving in the air. Hey, get on. This is once again a signal chain. So diaphragm's moving, that's the microphone, goes into a preamp. Preamp turns up the volume, and then once you have your volume turned up, you got to send the signal on to an analog to digital converter. So this converts the audio wave, which is the speaker going in and out, into ones and zeros so the computer can talk to it. And depending on your sample rate is the same thing. We're getting way too deep, aren't we? Sample rate, no, slow down. Sample rate in film, you got frames per second. So around 24 frames per second is the filmic look. Alright, and you get modern fucking slick looking YouTube videos that might be 60 frames per second. So digital takes constant, just like with film, takes constant snapshots of what is happening, constant pictures, and depending on how many pictures of how many times per second it takes a picture, the more accurate it can depict the vibrations in the wave. Alright, still with me? Maybe not. So it's all just to do with how many times it records the image per second. I'm looking for some numbers here to help me out. 44.1 that's a signal band. Not seeing any numbers help me out here. Alright, so that's your analog digital converter, okay? You can change how many times it takes the picture, and that's like sample rate. Alright, moving on. The reason 44.1 is used as a general sample rate is because it's double the frequency bandwidth of human hearing. So you got 20 Hz, 20 kilohertz. In theory, is the human range of human hearing. Not many people can hear above 16 kilohertz or hear. Not many people can hear down to low to fucking 20 hertz. You fucking mental. Well, in theory, a newborn baby could hear it. Could hear that range in theory. But your hearing stops dropping off from the day you're born. All the little hairs in your ears start falling out. Okay. So it takes 44.1 samples per second. And that covers the entire frequency spectrum twice over, plus a little bit. So they're like, right, if we just take this many frames per second, we'll have everything covered. Alright, so that's, yeah, and you can go up to higher sample rates if you want than that, but for CD quality and general things, 44.1 is where we're at. Alright, so that's just related, it's just waves and how many times you take a picture of a wave. So that's confusing enough, so don't worry about that one. You haven't even gotten to bit rate yet. 16-bit, 24-bit, floating, 64-bit floating. Anyway, so your diaphragm, I am the source right now, I'm moving the airwaves, it's causing the microphone to vibrate in and out, in sympathy with my voice or whatever. that little diaphragm. It's getting turned into ones and zeros so it could talk to the computer, and you can adjust how many times you want to take a picture of my voice. Alright. The more times, like one frame would just be like a picture. So anyway. Okay, and you need more frames per second to make it look moving. And the more frames per second you have, the less robotic it looks. The less like animation it looks. Alright. So it's in the computer. It's in ones and zeros. And it's coming up on a track on the computer. So I'd have to select the input. So I'd have to make a track. And you gotta make a track. You gotta, just like on a mixer, you gotta put the input into it. So instead of putting a cable from your preamp into your sound card, you're gonna have to digitally do it. So you're fucking you're selecting input on on the track. Right, there you are. And the output is set to the master mixer fader, and then it goes out into the computer sound card, gets turned back into the ones and zeros. You need a digital to audio converter, which is the inverse of an analog to digital converter, and they need to be synced up with a fucking tight ass clock, otherwise the frames per second won't be matching up. They won't be in sync with each other, so the frames per second won't line up, and it could be blurry and not great. Alright, so it's coming out of the computer in ones and zeros. Your after all your effects are done or whatever. So now it's going into your converter. The signal's coming out of your computer, but it's at a very, very low volume. The same way the microphone is at a very low volume, and we needed to turn it up with a microphone preamp, or else line level preamp, whichever you're into. It's +4 or something. Anyway, so just exactly, it's like full circle or whatever. So it's coming out at a low volume. You need to turn it up, so you need an amp. And it's not a preamp anymore, it's just an amplifier, like a speaker amplifier. So all this does is turn up the volume, and then that makes it loud enough to move the diaphragm of the speaker. So both the woofer, which takes care of the low end, that's the big speaker, and the tiny little speaker that's so small so that it can move in and out really, really quickly. Alright. It's all to do with speaker efficiency, and some speakers have like 2 woofers and 1 tweeter, and all sorts of things. Attempt to be able to fill a full frequency range. A lot of speakers have your earphones will just have like 2 little woofers. It's to do with covering the full frequency range. So generally they're divided into 3. You got your sub, which is all takes care of all that. So you've got one speaker doing that by itself. Then you got you also need a crossover for this, but anyway. And then you got your 2 woofers, which are left and right, and that takes care of pretty much all your sound, apart from the subs. Well, that's so your subs only taking care of your general woofers are taking care of everything else, and then and your cymbals and all that stuff is take care of the tweeters, because they have to move super fast to keep up with all the frequencies going on to accurately recreate the wave which you have that you put into the thing. Alright, so signal chain. And everything else is just fucking gravy. So you can turn it up and down if you want. You can pan it left and right if you want. You could add a time-based effect to make it sound like it's in a different room. That might be reverb. You could make it sound bigger and not farther away. Just make it sound thicker with maybe a little bit delay. Which echo. It's like a reverb, but it doesn't push it to the back of the sound field. Alright, so time-based effects. We got some housekeeping, such as like gates. So once the volume drops below a certain level, there's silence, so you wouldn't be able to hear things like my computer fan right now, which you can hear if I stop talking. If we had a gate, it would just chop out altogether. You just hear and be silence. So there you are. That's a gate. The compressor is similar to a gate. It's kind of like the opposite of a gate. So once you go above a threshold on a compressor, it starts to turn the volume down so that the volume doesn't clip. The transient doesn't blow the tweeter or whatever you have it. And that way you can control the sound and move it around. It'll stay in one place. Because if you have something like an untrained singer or something, their volume's going to be going up and down. So if you just have like an amateur magician playing a children's party or something, the dynamic range is going to be very, very bad. Like they're going to be playing softly and loudly, so you can press the crap out of it so there's no dynamic range, and then you can softly bring it up in the mix and it'll just stay there. It won't be going in and out. You'll be able to hear it sometimes, not be able to hear it sometimes. You'll always be able to hear it because the dynamic range is gone. And that would be an example of heavy compression. And there's lots of drawbacks. For example, if you compress an acoustic guitar that much, you may be able to hear the guitarist breathing like on top of the guitar track. Oh, that's the worst. The guitarist with sinus problems, it's fine. Just sometimes you're just compressing the shit out of something. You're like, where is that voice of death coming from? And you're like going through all the tracks, solo, and you're like, oh, it's just fucking guitarist, big sinus problems. Anyway, it's all fun. We all have our own things, don't we? It's fine. So signal chain, very important. So mixer, which we talked about yesterday, is for organising the volume. Basically, just organising the volume of your tracks. So if you have a live band playing, you got a microphone. You won't have a microphone, the drummer. You will not. You might have one in the bass drum or something. Maybe if you have a big PA. But anyway, so just organising the volume. Is the vocal too loud? Brilliant. We'll just turn it up, and then it goes all out through the master, bus, the full band. It's just for adjusting volume. And if you really want to, I only want to hear just the drum, and you press solo and you hear a squeaky drum pedal going run out to the other side of the glass, get some oil on that squeaky foot pedal, and then you notice the tom's out of tune and it keeps going. Anyway, recording live bands, the joys of life. Right, so mixers, signal chain, analog to digital converters, digital to analog converters, sample rate 44.1 kilohertz to something megahertz or something, I can't remember. Other little bits and bobs, that's good to know. Tracks go into your master track, master fader, happy days. You got your solo button, you got your mute button, you got your recording AO button, which you press on the track if you want to record over whatever's on that track. So be careful with that one. Record enable, you click a red circle on your track and it'll like stay there red. And then when you press record on your transport bar, it will record over whatever's on it or whatever. So you gotta select your input on the track, you gotta select the output on the track. On a hardware mixer, maybe as simple as just plugging your input into that track. On a digital one, you just gotta select what input you want on your sound card. flipping phase is the circle with the line through it. Metronomes and click tracks are the thing to keep you in time. Sometimes Control M turns that on and off. And it's important that you, on your recording session, you find the tempo of your song and have the tempo of the song in the session. But that's a lesson for another day, isn't it? Alright, so well done for keeping the head down. I'm throwing a lot of very advanced stuff at you, but it will all become clear in time. Congratulations. Hit the old Patreon and buy the merch, all that good stuff from us, official vegan Steven vendor. All the best. See you now. Subscribe.